In this video we are going to talk about how to draw angles, and to start this off I'm going to talk about what a reference angle is. And I know that I've probably mentioned this before, but what we're going to say is, let's say we have some angle and it's in its standard position, which means think about where it's located on the unit circle, where that terminal position is, the initial position being the x-axis, and where that angle would end, I suppose. Then it says the reference angle associated with theta is the acute angle formed by the terminal side and the x-axis. So, if the angle is in quadrant 1, then the reference angle is the same as the initial angle. Okay, so I don't have an example for that, but if it's in quadrant 1, just think about that, where any angle that's terminal side is in quadrant 1. Okay, so this will be in quadrant 1. The angle theta and its reference angle, which we're going to call theta bar, are in the same location, right? Because that's the acute angle formed by the terminal side and the x-axis. That is the same angle that you have drawn. Okay. Well, if the angle is in quadrant 2, so let's just say that I have some angle that ends up in quadrant 2. So the way I draw this angle, I always start at the positive x-axis. And I go to its terminal side there, so that would be the angle theta. The idea of the reference angle is it's the acute angle with the x-axis. So the reference angle for this one would be this angle here. So for example, if the angle itself was, let's say the angle was 135. We know that that is an angle in that has a terminal side in quadrant 2. Then the reference angle would be 45 degrees, because 135 is 45 away from the x-axis. So that's kind of what you want to think about. What that helps you with is determining the coordinate points there, right? So you know that 135 ends at, it's the same as a 45, so we know the coordinate points are going to be root 2 over 2, comma root 2 over 2, and we can associate the positive and negative depending on which quadrant we're in. Okay, so that's the idea of a reference angle. I'll go ahead and give you a couple examples of ones that are in quadrant 3 or quadrant 4. So let's say we have an angle down here in quadrant 3. Again, to draw theta, I start at the positive x-axis, go all the way around. In this case, theta bar is this angle. Okay, always go from the x-axis, the acute angle, the x-axis, and the terminal side there. So that will be a reference angle. So for example here, let's say that theta was 210, then theta bar would be 30, right? It'd be 30 past 180. So there's an example there. And then let's do something in quadrant 4. So let's go down here. So theta would look like this, and theta bar, again, acute angle to the x-axis, that's going to be this one. So let's say that theta were 300 degrees, then theta bar would be 60 degrees. That's 60 away from the x-axis, so 60 degrees there. So that's the idea of a reference angle, and also how to draw an angle. So on the following examples, I'm not going to necessarily worry about reference angles. What I am going to do is just simply draw what these angles would look like. So 60 degrees. We know that that is a more vertical angle in quadrant 1. So I'm just going to simply draw this and say theta equals 60 degrees. If I were to draw the reference angle there, it would also be the same exact angle. It would be 60 degrees because that's the acute angle with the x-axis. 5 pi over 4. 5 pi over 4 is the 45 in quadrant 3. So to draw that angle, it's going to be exactly in the middle down here in quadrant 3. And that is theta. It's 5 pi over 4. It's just a radian measurement instead of a degree measurement. Negative 210 degrees. Okay, so now we have a negative angle. So we've talked about in previous videos how to handle negative angles. But essentially what a negative angle does is it goes from the positive x-axis, and you go, instead of going counterclockwise, you go clockwise. So 210 would be 180 plus 30. So if I'm going in the clockwise direction, it's actually going to end up here in quadrant 2, And my angle, if I were to draw it, would look like this, and that would be negative 210 degrees. Okay, that's negative 180 plus another 30, negative 210. And then 17 pi over 6. Well, 17 divided by 6 is bigger than 2, so this is more than one full revolution. So I am going to subtract 2 pi to this to see where this does end up. So that's going to be 17 pi over 6 minus 12 pi over 6, if I get a common denominator there. And I get 5 pi over 6. So I know it's going to end up at 5 pi over 6, which is here in quadrant 2. But the fact that it's 17 pi over 6 means it was one full revolution plus the 5 pi over 6. So the way I'm going to draw this, again, starting on the positive x-axis, we go all the way around and then back to 5 pi over 6. And that would be an angle of 17 pi over 6. So you don't draw the angle 17 pi over 6 the same way you draw 5 pi over 6. The terminal side is the same, but when it comes to actually drawing it, you want to make sure that you do the number of revolutions required to get to that angle of 17 pi over 6.